You've probably seen a little bit of them already through various through various examples that we've done. But we're going to spend both today and tomorrow talking about objects in a bit more depth. Arrays are helpful for storing a lot of things, and that's what objects also do. But the difference between arrays and objects, and it's really something that makes objects extremely powerful, is that array is a list of things, right? And if I want to search for something in a list of things, I pretty much need to go through the entire list. And so it's not very efficient if my goal is to kind of find something really quickly. Um, Objects, on the other hand, are actually extremely efficient because objects are not stored in a list form. And when you search for things in an object, you pretty much just go to that thing and it either exists or it doesn't. And so objects are actually incredibly powerful, and we'll take a look at a few examples of that today. So the technical definition for an object is that it's an unordered collection of key value pairs, which is a lot of big words that probably don't mean much to you right now. One of the best examples that I've heard for describing an object is that it's kind of like a dictionary. And actually, in Python, an object is called a dict, D-I-C-T. So when I say an object is an unordered collection of key value pairs, or an object is a collection of key value pairs, that's the same as me saying a dictionary is a collection of word definition pairs. The analogy kind of works very, very well. So if an object is a dictionary, when I think about a key, I'm really thinking about the word. And when I think about the value, I'm thinking of the definition associated with that word, or the value associated with that key. And essentially, when I say an object is a collection of things, it just means, hey, it's a bunch of key value pairs all collected together. Just like how a dictionary is a bunch of word definitions all collected together. Now we saw with arrays that when we wanted to access a piece of information, we looked it up by a numerical index, right? We say look at the thing at the first position or the seventh position, and so on and so forth. With objects, we no longer have positions. We have, as to kind of further the dictionary analogy, we just have words. So if I want to look up the definition for the word house in the dictionary, I don't need to look up every single definition or every single word in the dictionary to say, hey, where's house? Where's house? Is this house? Is this house? I just go to where house should be, and either the dictionary has that word or it doesn't. And so that's what we mean when we say that's a key. That basically means the key corresponds to the word in the dictionary. And so when we look something up, it either has it or it doesn't. So here on line 6, we have an array. On line 8, I am also trying to store the values of value 1 and value 2, but now rather than having it associated with a position, notice how my object now is associating each value with a key. Just to make sure we're very clear on the syntax of an object here, on line 8, we start the object with a curly brace at the end of line 8 there, and we close the object with the closing curly brace on line 11. So very similar to what we do for a function. Every key value pair in an object is separated by a comma. So at the end of line 9, we see that the first key value pair, we see the comma, and that means on line 10, we have another key value pair. And the colon essentially separates the key from the value in a key value pair. So everything to the left of the colon is the key, everything to the right of the colon is the value. So on the left-hand side, we have key 1, and the corresponding value to that is value 1. And in the second key value pair, the key is key 2, and the corresponding value is value 2. On line 13, if I want to access value 1, I will look it up by the position. So here I'll say my array, position 0. To do it for a dictionary, I would just say my object, and rather than giving it position, I would just give it a key. In this case, I would give it the string key 1. Okay. Everyone good so far?
Yeah.
Cool. So why are objects useful? Because we can store a bunch of information. But more importantly than that, objects also, if you remember the keys from earlier, objects also allow us to associate the values with some additional pieces of information, the keys. So here, on line 2, if I have an array called Pusheen, and in it I store 3 objects, Pusheen, 7, and Gray and Tabby, well, that doesn't really, I know it's 3 pieces of information, but it doesn't really tell me that much. Instead, if I actually store it with an object, well, I can still store the values of Pusheen, 7, and Gray and Tabby, but now with each value, I can associate a key with it. So here on line 11, for Pusheen, I associate with the key name. On line 12, I associate the key age with the number 7, and so on and so forth for color and gray and tabby. And so now not only am I storing kind of seemingly random pieces of information, I can now associate a key with it that both makes it easier for me to access, but also gives me a little bit of context around what that information is supposed to be. Type of an object is an object, so nothing too fancy there. And when we create an object, once again, we make sure to use our curly braces. Now, this object here on line 6 is the same object that we saw earlier, except the only difference here now is that on the key side, notice how we took away the quotes. And this highlights a very important fact around JavaScript objects, which is that the keys are always strings. Okay, the keys for the object can only be strings, just like how usually when we have a dictionary, the words have to be alphabetical, right? The definition for a word could be a graph, it could be a picture, it could be other words, it could be other things, but the word itself needs to be alphabetical. Same thing here for JavaScript objects. The values can be anything. Here we have 2 strings and a number, right? Pusheen and gray and tabby are both strings, and 7 is a number. But when it comes to the keys, name, age, and color, those have to be strings. And because those always have to be strings, what JavaScript will actually do on your behalf is it'll take whatever key you give it and it will convert it into a string for you. And so therefore, you don't even need to put quotes around it, because the assumption here, kind of like the use contract here, is just to say, well, of course, name is a string, right? It can't be anything else. And so what JavaScript is doing is behind the scenes, it's actually converting that to a string for you, whether or not you intended for it to be a string. If you had written a number there instead, it will just convert that string into a number for you. And so once again, the keys are always strings, and because of that, you can omit the quotation marks when you write it. For accessing a value, we saw an example earlier. We still do the whole the object, and then we use the bracket notation. But once again, instead of putting the numerical position as we did for arrays, now we're putting in the key. Here we have to put in quotes around the name. Why? Because here, between those square brackets, we can put in a string, but we can also put in a variable or something else, right? And so because there's flexibility in what goes in between the brackets, we need to explicitly say this is a string. And that's different from line 6, 7, 8, where in the keys, that key cannot be anything except a string, and so therefore we have to put in. So therefore we don't have to put in the quotes. On line 11, 12, and 13, notice how we're doing name, age, and color. And then on line 14, we did something that we also did for arrays too, which was we essentially try to access a key that's not in the object. And lo and behold, the same thing happens, right? Name, age, and color, I get back 7, or Pusheen, 7, and gray and tabby. But when I try to access the value corresponding to a key that's not in the object, I don't get back an error. I simply get back an undefined. Everyone still with me so far?
Yes.
I actually had a question. Since you're returning line 7, like the age of 7 as a string, would you, when you like log that or I guess return it, would you need to do like the number function and it would
No. So 7 is to the right of the colon, and so that's the value. So the value can be any data type you want it to be. In this case, a 7 is still a number. The only thing that has to be a string is whatever's to the left of the colon.
The key. Okay.
Yeah. So name, age, and key name, age, and color are the keys, and those are strings. The values can be whatever data type you want it to be.
Okay, I'm sorry, I totally missed that.
Yeah. No problem. Any other questions? Okay, great. Yep. So here we can put anything we want in between the square brackets, including variables. On line 10, we create a variable called key to check. We give it the string name, and so we can put that in between the Pusheen object. We can put in 2 strings that we're adding together, and in both cases, it will work. And so it's just a little bit more flexible this way. This is pretty standard. Like we did it for arrays too. Remember how we were doing array index of I? I is just a variable that corresponds to a number. Here, we can also put in variables here that correspond to strings. Another thing that makes life just a little bit easier, and it's more of a shortcut, is that you can also use something called dot notation instead of bracket notation. Here on line 11, notice how what we're doing is we're still accessing pushing.name, except now we just do, oh, sorry, we're still accessing the name key associated with a pushing object. Except here, rather than using the bracket notation, what we're doing is we're actually just basically using the dot notation, and we just do dot name. Now, there's no quotes around the dot name because wherever you do pushing dot something, it means you're feeding it the exact name of the key. Okay, so what that means is here is that we cannot use variables anymore. And in fact, on line 9, notice how we created a variable called key to check. We set it equal to the string name. On line, so I can do pushing.name, pushing.age, pushing.color. On line 14, when I do pushing.key to check, it's not looking for the variable key to check and then converting it to name. It is literally looking for a key on the object called keytocheck. It's looking for a key called key to check. And so with name, age, and color, we get back the right thing. But for key to check, we get back undefined. Okay, dot notation is meant to be a shortcut. It will work in the vast majority of cases, but there are cases in which it won't work. For example, if I have a key that has a space in it, so if I do, name space last, well, I can feed in a string called namespace last, so I can use bracket notation for that. But I can't do that with dot notation. And so if you're ever in doubt, just remember, bracket notation will always work. Dot notation is a shortcut that will work most of the time, but not every time. Adding a key value pair is pretty straightforward. It's the same thing as we did for arrays, right? We just do the object and we specify the key, and we use our assignment operator, the equal sign, and we give it the right value. So here we're giving Stormy and Pip values into the pushing object, and we can do it with either bracket notation or dot notation. So here we've added 2 more key value pairs, and then changing a value, the same thing. We literally just do what we did before, except we still use our assignment operator. We're now just overriding the previous value, or we can do something like pushing.age++, which all it does is it increments a number by 1. Deleting a key value pair is something that exists. I would say I've actually never seen people really use it. And so the delete is a reserve order JavaScript. You can say delete pushing and then give it a key, and it'll delete both that key and that corresponding value. The analogy, I guess, going back to the dictionary is, well, if you have a dictionary, you wouldn't go through and delete the words that you don't use, right? You just don't use them. And typically speaking, that's how people handle objects too, is that you very rarely delete key value pairs, you just simply don't use them. The main reason for why someone would delete a key value pair is if you have, let's say, a username or a password or something kind of very sensitive in an object, and you're about to pass that object onto someone else, you could either recreate the object without without the sensitive information, or you could delete the key value pairs from the original object. But it's more of an edge use case, and I would say that in general, people don't really delete key value pairs. They just tend to either recreate the object, or they just leave it in there and opt not to use it. Yep. Okay. So I think on Monday, someone asked about the for in operator. And so we're going to talk a little bit about it. With an array, I can use a traditional for loop, right? And say, hey, because I know the length of the array, I know every number between 0 and that length is going to have a position in the array. So I can actually go through the array. With a dictionary, it's actually really hard to quote unquote go through the dictionary in a very linear fashion, and so that's where the in and the for in loop and operators really come in handy. The first part of the for in loop is just the in operator, and it works as probably one of the easiest operators in JavaScript. You just give it a key, you use the in keyword, and you give it an object. If I do name in pushing or sadness in pushing, that will basically return for me a boolean, and it'll basically say, does this key exist in this object? So in this case, a name key exists and the sadness key does not exist. So whenever I use the in operator, all I'm ever going to do is get a Boolean value. If I combine this with our for operator or our for loop, then we get something called a for in loop. And it's a very powerful thing. It looks somewhat similar to the for loop, but just different enough that you probably want to pay attention in terms of how we use it here. So on line 9, we have the basics of a for loop, right? We say for, and we do let key in pushing. Okay. Let is our way of creating a variable, much like how when you have a traditional for loop, we say let I equal 0. Well, in this case, key is just I. It's a random variable name. I can use any word I want in there, right? So I'm creating a variable, and I say in, and then the name of the object. And what now this will do is this is going to create a loop that's going to iterate through every single key in my object. Okay. The important word here is to recognize that the for loop will go through every single key in your object. Okay. You don't have to specify, oh, go through every one. By default, it will go through every one. And in fact, it has to go through every one. And so one question I usually get is, well, what if I only want to go through half the object or half of the keys in the object? The answer is don't use a for loop, right? Find another way to do it. So the for loop will automatically go through every single key in the object for you. And each time it goes through it, the variable key takes on a different key value. Or sorry, takes on a different key quote unquote value. Just like how when I use a let I equal 0 for a normal array loop to iterate through a normal array, every iteration the I assumes a different number. Here, on every iteration, in this case, the variable key assumes a different key, right? And so here, if I do console log out, Pusheen's key is the Pusheen, and then the value associated with that key. I actually get to go through and print out more or less the entire object. Pusheen's name is Pusheen, Pusheen's age is 7, Pusheen's color is gray and tabby. This making sense to folks?
Yes. Yep.
Cool. Awesome. So once again, the for loop will go through every single key in the object. And one thing to note here is that because key is assuming a different value each time, we can't use line 10 there. We can't use Pusheen.key anymore. Why? Because remember, what the dot notation does is saying, hey, here is the actual literal name of the key. Well, if we're using key as a variable, if we do Pusheen.key, all we're literally looking for is looking for the key every single time we go through the object. And obviously that's just not good, right? Because the key doesn't exist in the Pusheen object. And so therefore when we print out through 3 times, we get back undefined 3 times.
I have a question for
yes.
the for in loop. Can we use any variable? Like, does it have to be key?
Nope, it can be any variable name you want.
Okay.
And in fact, using key here is actually very misleading, so we might change it for a later version of the slide. Okay. If you do, however, want to get back all the keys, just the keys in the object, what you're able to do is use something called object.keys. Notice how the capital O in object means now we're dealing with the object class. We're calling the .keys method on it. And if we do object.keys and we pass in Pusheen, the Pusheen object, we get back an array with 3 strings, name, age, and color, which are just a list of the keys. But once again, if you want to go through everything in an object, the for loop is by far your best and easiest way to do so. And last but not least, just like how we had nested arrays, which are arrays that hold other arrays, same thing with objects. We can have others that hold, or we have objects that hold other objects. And in fact, here, if I do Pusheen.colors, it's an array. If I do Pusheen.color index 0, well, because the computer reads it from left to right, it will say Pusheen, that's an object. Pusheen.color, that's an array. Pusheen.color index 0, that's a string. And so we're actually able to do this and access all of the information inside the individual values as well, if we just chain together all these different operations. And yep, and so before we had nested arrays, here we have nested objects, right? We have a Pusheen object on line 7. The value for siblings key is another object. And inside that object, there's other keys, and there are other key value pairs. And so, for example, if I want to get to Stormy on line 13 there, I could just do Pusheen.siblings, which would give me the object, .sister, which would give me the value associated with that sister key, which is a string, which is Stormy. I can do the same for dot brother as well. And so here I use dot notation. I could also very easily use bracket notation here as well. It works the exact identical way. I think that's it. So just to recap, we talked about what's an object and type of objects. We talked about accessing, adding, and changing and deleting values. I think those are fairly straightforward because they operate very similar like we've seen for arrays. The big thing here is really the for in loop, which allows you to iterate through and go through every single key in the object. Once again, remember the for in loop is designed to go through every single key in the object, right? So even if you don't want to use every key in the object, you need to still look at it and figure out some way to handle it in the body of your code. And then the last but not least, object.keys gives you back an array of the keys. And then just like how we have nested arrays, we can also have nested objects as well. And the way to access it is very much the same way we accessed nested arrays, which is we just chain together multiple operations to get to the inner information. So any questions before we get started on the workshop for today?
None at the moment, but I do see what you mean by stating that it's deceptively simple.
Yeah.